Okay guys, today we are going to continue with coordinate geometry. We're going to be looking at the equations of circles and ellipses, which now are both on, or could be on the ACT. So first we're going to start with the equation of a circle. I'm on page 326 here, and I just want to look at this a little bit closer than what the book does. So here's the equation of a circle. Notice that the x's are being squared, the y's are being squared. They're on the same side of the equation, and they're always being added, and then it's always equal to r squared. So I just want to show you an example here. If I had x plus 3 squared plus y minus 2 squared equals 49. This would be an equation of a circle. There are two main things that you need to be able to pick out from the equation: where the center is and what the radius is. The center of the circle is always found by using these two values here and just switching your signs. So you start with the x's. Since it's a positive 3, I'm going to switch the sign. So my x coordinate is going to be a negative 3. Same with the y's. I have a minus 2. Switch my sign so I get a positive 2. So the center of this circle is at negative 3, 2. The radius is always found by using this number. Notice the equation says that it's always equal to r squared. And so to find the radius, I just always need to take the square root of whatever that number is. In this case, it's 7. Okay, so then I could graph that circle, right? Start at my center and then go left, right, up, and down 7 units. Use that to draw a graph of my circle. So if we look at this first problem here, it says a circle is tangent to the x-axis and the line y equals 6. Which of the following equations could describe the circle? So first thing, tangent means touching at one point. Okay, so I'm going to go ahead and draw a picture here to help me. I have the x-axis, say there, and then the line y equals 6 is a horizontal line up at 6. So a line like this. So it says that the circle is touching at one point the x-axis and the line y equals 6. So I know it's got to be somewhere, in this path like that. So my center has to be right at the middle, right? So it's got to be somewhere on this line at 3. Okay? That also tells me that my radius right here from the center to the outside has to be equal to 3 units. So my equation, when I set that up, I know that on the equals part, the right-hand side, that's going to be 3 squared, which is 9. So I can go ahead and eliminate anything over here that is not set equal to 9. So these 3. So now I just need to see between the two that are left, which one makes sense to be the center. This one would have a center at positive 5, positive 3. This one would have a center at negative 3, positive 6. So at 5, 3, that would make sense because it's on that line at 3, right? Negative 3, 6 would not make sense to be the center of the circle. So the right answer here is B. It says some pointers for questions about circles. Use process of elimination heavily. Plot the information given and then sketch the circle and then eliminate wrong answers. So number 54 here, a circle in the standard xy coordinate plane is tangent to the y-axis and has its center at negative 4, 3. Where is the point negative 3, 0 located? So let's do our best here to draw hopefully an accurate picture of what's going on. Okay, the center is at negative 4, 3. So I'm going to draw that. And then it says it's tangent to the y-axis. Y-axis is here, so it means it's touching at that point. So that gives me the radius right here has to be 4. So from the center, I'm going to go ahead and draw 4 units, left, right, up, and down, so I can get a picture of what this circle looks like. Okay, so again, something like this. So then the question is, where is the point negative 3, 0? So if I look at that point, negative 3, 0 looks like there. It looks to be inside the circle. Okay, the next equation that I want us to look at is the equation of an ellipse. Now first, they don't have this set equal, but it's similar to a circle. You still have that x minus h squared, the y minus k squared. The difference is that now we have fractions underneath each one, and it's always going to be set equal to 1. Okay, so what's under the x is telling us how far left and right we're going to move to find our endpoints, and then what's under the y tells us how far up and down we're going to move to find our endpoints. Whatever I'm adding or subtracting to the x and the y still gives me the center. That's the same, just like it was with circles. Okay, so I'm just going to give us an example here that we can graph. If I have x minus 1 squared over 4 plus y plus 5 squared over 16 equals 1. This would be an equation of an ellipse. Okay. The center of this thing would be at positive 1, negative 5, just like we talked about with circles. So then I look what's under the x's, and this is going to tell me how far I'm going to move left and right, always. And again, if you look up here, right, it's not just the a, that's how far you move left or right. We need to take the square root of this to figure that out. So the square root of 4 is 2, which means I'm going to be moving left and right 2 units from my center. So if I just draw a rough sketch here, 1, negative 5, there's my center. I'm going to go left and right 2 units. Okay. Next, I'm going to look underneath the y's to tell me up and down. Again, I take the square root. Square root of 16 is 4, which means I'm going to be moving up and down 4 units here. I'm going to go off of my graph, of course. So this should be a little bit longer here. But this gives me my ellipse. Left and right 2, up and down 4. It should be a little longer like that. But that is how I graph an ellipse. Okay. So here is my problem. Shown below in the standard xy coordinate plane are a circle and an ellipse, both centered at the origin. The ellipse has the equation x squared over 49 plus y squared over 16 equals 1 and intersects the circle at only 2 points, both on the y-axis. Which of the following represents the equation of the circle? So this we know is at 0, 0. For the ellipse, right, the x squared over 49, that 49 is telling me left and right. I take the square root. So I know that I'm moving left and right 7 units here. So this point is at 7, 0. This one is at negative 7, 0. I look under the y's, so the 16, again I take the square root. That gives me my 2 endpoints here. So this would be at 0, 4. This would be at 0, negative 4. You can see that that is where the circle touches as well. And so I know that this distance right here is 4. So when I set up my equation for a circle, I know it's going to be x squared plus y squared equals 4 squared, or x squared plus y squared equals 16. So my answer for this one is J. Okay. Let's go ahead and flip to page 339. You can pause here if you want to. I'm just going to go through. There's only 2 problems I want you to work through on this one. So first one is number 31. In the standard xy coordinate plane, what is the center of that circle? This one should actually be pretty straightforward because it's set up perfectly as the equation for a circle. So remember that we take what's being added and subtracted to the x and the y, and we just switch our signs. So 1, negative 3. So this is actually a really easy problem if you recognize the equation of the circle, right? If not, then you may be stumped on this one, which is annoying because it does take such a short amount of time. Okay, so hopefully you'll get this pattern of the equation of the circle down. And then the other one, shown in the standard xy coordinate plane below, is an ellipse with this equation. Which of the following ordered pairs represent the foci of the ellipse? So we didn't really talk about foci, but foci are points that are always inside of the ellipse. They're always on the longer axis. So if I just draw on here, these are the 2 axes of an ellipse, okay? This one going horizontal here is longer in this ellipse. And so I know that my foci are always going to be somewhere inside the ellipse on that longer axis. And so the equation that I use, if I wanted to use an equation to find it, would be a squared minus b squared equals c squared. But you probably don't have to have that memorized. As long as you have an understanding of where the foci should be, you can probably figure this out just using my solutions, okay, or my options. So kind of just as an estimate where I drew my stars, I want to see if I can figure out where those would be, or which answer is correct here. So let's see, here's 0, 6, and then 18, 6. That doesn't make sense because it can't be on the edge. So these two that have 0, 6 have to be eliminated. 2, 6, and 18, 6, that seems to make sense. Let's make sure that no other ones do. 10, 0, and then 10, 6, no, because those are on the ellipse. And then 10, 6, and 10, 12, those would be, let's see here, 10, 6, and 10, 12 would be up here. That doesn't make sense. So, nope, has to be H. Again, foci are always on the longer axis inside the ellipse. All right, guys. Good job. Thanks.